I know it can seem silly to claim that our body is ever in static equilibrium. It feels like there's always something moving inside of us, be it our hearts, our lungs, our abdomen, or our muscles. But when we think of our skeleton, and more specifically our bones, as rigid bodies, we can play around with the idea that there are many situations where it can be accurate to assume static equilibrium in our physiology. That's because, in this case, static does not mean not moving, it means not accelerating. Picture a body, not necessarily human, it could be anything. Now let's imagine that it is at rest or that it is in motion, but with a constant velocity. Knowing Newton's first and third laws, we know that for this body to be in static equilibrium, the sum of its external forces must be zero, and the sum of its external moments must also be zero. Note that the moments in this case are being taken around a fixed point titled O in the body. I'm not going to place it somewhere in the body because really it could be anywhere. Knowing that these sums must be zero, we now have some equations to play with. We can then solve for specific forces or moments in each scenario. That's when we really start solving for unknowns in our system. We will be using force and moment balance equations, but in solving for our unknowns, it is important to remember that the number of unknowns and the number of balance equations we have must equal. When that happens, the system is statically determinate. Depending on the system you are dealing with, you can get a pretty good idea of what your balance equations will be. If you are dealing with a 2D system, you can only have forces in two directions, x and y. In a 2D system, you can only have moments in one direction, z, since we only have one plane and the moment must be orthogonal to the plane with the force and moment arms. Thus, we can only have up to 3 balance equations in 2D. This means that we can solve for up to 3 unknowns. On the other hand, in 3D, we can have forces in all 3 directions, x, y, and z. And we can also have moments in all 3 directions, x, y, and z. As a result, we can get up to 6 balance equations in 3D, and they are all equaling 0 in static equilibrium. This means that we can solve for up to 6 unknowns. When we have too many equations and too little unknowns to solve for, our system is overconstrained. We tend to then call this system indeterminate because it is redundant and solutions are not unique if they exist. When our system has too many unknowns and too little equations, our system is underconstrained. In these cases, we tend to call these systems unstable. I'm going to attach a source that explains this in a lot of detail if you want to learn more. This all has a lot of potential, so let's go ahead and end right here and tackle even more next time.